Now I will start the assembly process for the linear slide. I'm gonna go to File and open an assembly file. So for this one, I'm simply gonna bring in the base frame first. And I'm gonna drop it in there. So there's the part, and I'm gonna change the unit to mmgs, and I'm gonna save this file as linear slide assembly, and you will use your student ID. So I'm simply gonna add that as well. Lab 3 just for the completion. All right, so the next component, I'm gonna go to insert components, and I'm gonna bring in a motor solid part, and I'm simply gonna drop it somewhere there, and I'm gonna go back to insert component again. I'm gonna browse, and I will bring in the gearbox. So, and now I'm gonna make the assembly for the motor and the gearbox first. I'm gonna add some mates there. So I'm just gonna position it like that. The first mate I'm gonna add, I'm gonna click on mate, and I'm gonna select this face, and I'm gonna select this face, and I'm gonna make them concentric. And the next one, I'm simply gonna go across here, and I'm gonna select this face, and I'm gonna select this face, and I'm gonna make it concentric. So now this is positioned. The next mate I'm gonna add is, I'm gonna select this face, and I'm gonna select this face, and I'm gonna make them coincident. So now I will add the mates between the motor and the gearbox with this base frame. I'm gonna go to assembly tab, I'm gonna click on mate, I'm gonna select this face, and I'm gonna select this face, and I'm gonna make it concentric. Make sure when you're doing the assembly that this is the flat face on this side. That's how it should be positioned. And this face and this face, I'm simply gonna make them parallel. This face and this face coincident. So the next component I'm gonna bring in, insert component, I'm gonna browse, I'm gonna bring in the guide rail, and I'm simply gonna drop it there, and I'm gonna rotate this one in a way that I will position it like that. So I'm gonna add concentric mate. I'm gonna go to the mate icon, and in here I'm gonna specify this face, and I'm gonna specify this face on the second hole from the motor, and I'm gonna click OK, and then I'm gonna go on the other side, select this face, and I'm gonna select this face and concentric again, and then I'm gonna select this face, and I'm gonna rotate this model. I'm just gonna move it out so that it's easier. Oops, I'm gonna clear this selection. I'm simply gonna move this away a bit. So I'm gonna select this face, and I'm gonna select this face, and make them coincident. So this is how it looks. And now I'm gonna bring in the another component, and the next component I'm gonna bring in by going to insert components. That's linear carriage. So I'm gonna drop it there, and I'm gonna rotate it and position it the way I want it. So I'm gonna position it in this direction like that. And once I have positioned it, what I'm gonna do is I'm gonna select this face, I'm gonna click mate, and I'm gonna select this face, and I'm simply gonna make it parallel mate there, and I'm just gonna move this one a bit here. And now I'm gonna rotate this in here, and I'm gonna select this face, and I'm gonna turn around, and I'm gonna select this face, and I'm gonna make a distance mate there, and I'm gonna set this one as 0.1 millimeters. And I'm gonna click OK, and then I'm gonna select this face, and I'm gonna turn around, and I'm gonna try to get this face, and I'm gonna make a distance mate again. I'm gonna make it as 0.1 millimeters, and I'm gonna click get out of this dialog. So now this linear carriage basically slides on that guide rail. Now I'm gonna bring in my next component. The next component I'm gonna bring in is going to be the mounting hub. I'm simply gonna bring and drop it there. Gonna turn around, and I'm gonna bring in the bearing. I'm gonna go to insert components. I'm gonna bring in the bearing part. I'm gonna drop it there, and I'm gonna bring in another bearing as well, so that I have both of them there. And now I'm gonna start adding the mates. The first mate I'm gonna add is concentric. I'm gonna click OK, and I'm gonna just move this one here. And now the second mate I'm gonna add, I'm gonna select this face, and I'm gonna select this face, and I'm gonna make them coincident. And now I'm gonna select this face. For the second bearing, I'm gonna make it concentric. And again, same thing. What I'm gonna do is I'm just gonna move this one out here a bit, so that I can line things up. So I'm gonna select this face, and I'm gonna turn around, and I'm gonna select this face, and I'm gonna make it coincident. And now what I'm gonna do is I'm gonna bring in the next component. I'm gonna bring in his retaining ring. I'm gonna drop it there, and I'm gonna start adding the mates. And simply gonna select one of the cylindrical edge or face to make it concentric. But my ring has gone in, so I'm simply gonna select this. I'm gonna move this one out, and the next mate I'm gonna add is I'm gonna select, we just want to get the right one. Yeah, I'm gonna select this face, for example, and I'm gonna select this face, and I'm gonna make it coincident. And I'm gonna simply copy this retaining ring on the other side, and I'm gonna select this, and I'm gonna copy with mates, and I'm gonna click OK. For concentric, I'm simply gonna select this. For the other mate, I'm gonna select, for this one, I am gonna select this face. And I'm gonna exit the mate dialog. And I'm gonna bring in the another component now. So the component that I'm gonna bring in is the shaft that you designed for lab 3, and I'm simply gonna bring it in here. I'm gonna rotate it like that, so I line up properly. So I'm gonna add some mates I'm gonna select this. I'm gonna select this cylindrical face, and I'm gonna make them concentric. And I'm just gonna move this one on this side. I'm gonna select, for example, this face and this face, and I'm gonna make it coincident. I'm gonna click OK. So this is how it looks. And now I'm gonna bring in the mounting bracket. I'm gonna mounting bracket. I'm simply gonna drop it in there, and I'm gonna select this face, click on mate, select this face, and make it concentric. So this fits here, and I'm gonna select this face, and I'm gonna select this face and make it coincident. Gonna select this face and this face, make it parallel. So this is this part is done. And now I'm gonna add the mates over here. Select this face, select this face. I'm gonna make it parallel, and I'm gonna select this face, and I'm gonna select this face, and I'm gonna make it concentric, and I'm gonna select this face and this face and make it coincident. So now I will import insert another shaft in the assembly for the motor side. I'm simply gonna rotate it so that it positions properly. I'm gonna click on mate, select this face, select any cylindrical face on the motor, make it coincident. The next mate I'm going to add is a distance mate between this face and this face, and I'm going to add a distance mate of 43.7 millimeters. And click OK. And exit the mate dialog. And now I'm gonna bring in the timing pulley. Timing belt pulley. I'm simply gonna drop it there, and I'm gonna add a few mates. And I'm gonna add, I'm gonna select, click on mate, gonna select this face, and on the pulley side I'm simply gonna select this and make it concentric. And the next mate that I'm gonna add is a distance mate between this and this, and it is 0.1. Gonna click OK, and I'm gonna exit the mate dialog. And now I'm gonna copy this timing belt pulley with mates. I'm gonna right click on it, and I'm gonna select copy with mates, and I'm gonna click on this arrow. So the first with the concentric, I'm simply gonna select this face, and for the distance I'm gonna select this face, and I'm gonna click OK. and I'm gonna exit the dialog. Now I'm just gonna change some of the appearance for these components. Few of the components I'm simply gonna select. I'm just gonna change the appearance so it looks a little bit better. This one, for example, I'm just gonna select this, click OK. For the base, oops, so I'm just changing the appearance so it has some contrast for the future steps. Now we'll add an assembly feature with the belt and chain. To do that, I'm going to go to Insert, and I'm going to go to the assembly features, and I'm going to select belt chain. And in there, in the dialog, I will select this circular edge so that I can pick up the diameter. So this is where basically the belt would be added. And I'm not gonna select driving. This one I'm just gonna leave it, and I'm gonna select this create belt part, and I'm gonna click OK. So this is there in the manager, in the assembly manager here. We have this belt has been created. However, the belt part is not there. To do that, if we want to design the belt part, we simply need to go right click on it and open in its position. So this opens the sketch, and in here we could specify the thickness for the belt and so on and so forth. And to do that, all you gotta do is simply select extruded boss base and select this sketch, and under the specifications I'm gonna specify the depth to be before doing anything, I'm simply gonna change the units to mmgs, and I'm gonna save this part. And now I'm gonna click on the extruded boss base. I'm gonna select this sketch, and under here with the parameters I'm gonna specify 26, and I'm gonna switch the direction because I know this is the edge that will be facing the pulley, but we can always come back and change it. And I'm gonna select this thin feature, and the direction I'm gonna select this so it the thickness is added outwards, not the inwards. That's where I'm gonna do it. And the thickness I'm gonna simply select 5, and I'm gonna click OK. And I'm just gonna change the appearance to for this part, I'm simply gonna select some color here, red for example, and I'm gonna save this part, and I'm gonna go back to the assembly now to see how the assembly looks. So the belt part has been added, but the direction that I have added my belt, it's going through, so I need to come back and change my direction. The sideways we are fine, so I'm gonna go back to my belt part, All right, so this one I'm gonna right click and edit the feature, and the direction I'm gonna change. Originally I had the correct direction, and now I'm gonna go back and see my assembly, and I'm gonna update, and this is what I want. Okay, so now if I rotate this, as you can see, the other pulley is rotating in the same way, so it has already added the mate there as well. And I'm gonna click OK. All right, so this is the part. You can simply hide this one if you want you don't want to look at the sketch. So I'm not looking at the sketch anymore. But if I rotate my pulley, it is rotating in the same direction. And now I'm gonna move on to the next step. In the next step, I'm gonna add the carriage mount, and I'm gonna bring in the component by clicking on Insert Components, and I'm gonna bring in carriage belt mount. I'm gonna drop it in there, and I'm simply gonna just rotate it, and here I'm gonna add a couple of mates. Gonna click on mate, gonna line it up in that direction so it will line up better. So I'm simply gonna select for example this face and this face, and make it concentric, and I'm just gonna move this one out of the way. I'm gonna select for example this one, and I'm gonna select this one, and I'm gonna make it concentric as well. And the next one, I'm gonna select this face, and I'm gonna select this face, and I'm gonna make them coincident. So now this sits under the belt. So I'm gonna insert the last component for this assembly. I'm gonna browse, and I'm gonna simply bring in the Lab 3 belt gripper, and I'm gonna drop it there, and I'm simply gonna rotate it like that. And now I'm gonna add the mates, and I'm gonna simply select one of this hole and this hole and make it concentric, and I'm simply gonna grab and move it, and I'm gonna select this hole for example, and I'm gonna select this hole, and I'm gonna make them concentric. And the last mate I'm gonna add is I'm gonna select this face, and I'm gonna select this face, and I'm gonna add a distance mate, and I'm gonna put around 8 millimeters, as long as it just doesn't go in. Yep, so 8 millimeters, and that's where your carriage is, and that's where I'm gonna exit the mate. So if I rotate the pulley right now, there's no relationship between this carriage and this pulley. So what I'm gonna do is I'm gonna add mate, rack and pinion mate, so that when I rotate the pulley, timing belt pulley, so this will slide on the guide rail. So to do that, I'm gonna click on mate, and in this case we're gonna add mechanical mate, and from there we're gonna select rack and pinion. And under here, the specification that we're gonna specify is for rack, we simply gonna select this. For pinion, we're gonna select this, and we're gonna specify the rack travel per evolution. And this one I have chosen 50 millimeters, but this is incorrect physically. I picked this number to basically demonstrate, so when you're running your simulation, when you're rotating your pulley, so that you will have some turns. So it's just for the demonstration purpose, otherwise I will pick the proper parameters there. I'm gonna click OK. Now we're gonna see the impact of this. So as you can see, I'm rotating it, so if it rotates in this direction, so it moves. Okay, so it's slide, so this assembly is good. So we're gonna save this assembly, and I'm gonna rebuild and click OK to any pop-up. So now we are ready for the motion simulation. For the motion simulation, to reduce the computational time, it is highly recommended that we simply fix the components that are not going to be moving. In this simulation, only the pulley and this carriage would be moving. The rail, motor, and other components, all of them would be simply stationary. So what we're going to do is, you can simply select right click, fix component one by one like that, or simply you could go select the components that you want to fix at once. This one we want it to be moving. Bearing, all those yeah, so right click, I'm simply gonna fix them. So I'm gonna test my assembly. It still works the way I need it to work. So now we will move on to the motion simulation for this linear slide. Similar as lab 2A, please ensure that your SolidWorks motion add-in is activated, and this could also be done from going through under the tools and selecting. You could select add-ins from there, and then you could select the motion, SolidWorks motion there. So once this is active, now we will do some exercise where you will learn a little bit more features associated with the motion studies, which you can conduct in the SolidWorks. So to activate, all simply you got to do is click on this motion study. So in here, the first thing first, I will follow the steps as closely as possible. So in here, you want to select motion analysis, which gives you the more details. It can solve for motion, for, various parameters like acceleration, position, displacement, velocities, as well as it can calculate the forces, torques, and so on and so forth. And it's the most realistic motion simulation that you can do in SolidWorks using the motion analysis setting. And the next step, what I'm going to do is simply I'm going to right click in here. I'm going to disable this playback keys. And now I'm going to add a motor. Simply gonna click on this motor, And now to add the motor, simply select that. So if it rotates in this direction, then the carriage will move around there. And for the motor parameter, we're gonna play around a little bit. We will program the motor with the different methods. So we're gonna set for the first one, the motor speed motor will run on a constant speed with 120 RPM, and I'm gonna click OK. I'm just gonna move this carriage over here so that it has more distance to go over. To calculate the motion, what I'm gonna do is I'm gonna set my settings. I'm gonna set as 100 frames per second. I'm gonna click OK, and I'm gonna hit solve for the motion. So the motion is done. I'm gonna just simply play. So it is working the way I have programmed the motor. And now I'm gonna review my parameters over here. Right, still, even though I have fixed many components, I still have about 17 mate redundancies. So I'm going to remove those redundancies now. To do how that can be done, you simply click on this motion study properties, and under here you replace redundant mates with bushings. It always does not work. This is the reason I had to fix some of the components. It is an automatic tool, but sometimes it won't work. So whenever you're planning to do any motion study, motion analysis to improve your design, always plan ahead. I'm gonna click OK, and I'm gonna solve it again. And now let's review the mates again. So there's zero redundancy. This is what I want. I'm simply gonna save this file. Okay, now I'm gonna copy the studies. To copy the study, you could create a new study, or you can simply copy all the parameters. So now the motion study 2 has been created. So now we will program this linear slide with the different method. To do that, what we're gonna do is I'm gonna delete this rotary motor, which is copied from the previous study, motion study 1. And now I'm gonna add a motor, and in this step, I'm simply gonna select linear motor. Now I'm gonna program the motion by selecting this edge and by specifying the direction, and I'm gonna program it with this one with the constant speed. And the constant speed I'm gonna specify as 50 millimeters per second. And once the motor is defined, I'm simply gonna click on the calculate icon and let it solve. So in this way, what we are doing is we are basically specifying the motion for the carriage, at what speed we want to move it to. So there are many useful tools that are available in SolidWorks that can help to refine your design depending on what your design intent is. So if I play this motion, so this is moving in. And now I'm going to show you how to program this motor slightly differently, so that can help to program and figure out few parameters. So there's many options available, such as there is servo motor, there's expression, data point segments, and oscillating and distances. There is many methods of programming your motor, and they become handy when you're refining your design. So what we're gonna do is we're gonna program this motor now with the segment functions. So we're gonna design the segment. So to do that, we simply click add rows, and we're gonna program it till 5 seconds. Okay, 5 to 6 seconds, and we can specify the positions, displacement, velocity, and acceleration to define our motion parameter. In here, we're gonna define, as it's specified in your manual, we want to move from 0 to 1 second. We want to move that carriage by 200 millimeters. I'm simply selecting this and entering the information. And for the next one, next second, 1 to 2, we want to move it by 50 millimeters. So we are changing the speed. And this is what happens in the automation lines, that your grippers and so on and so forth, or the handling units, they need to move at different speeds. So next one is 300, and this one I'm gonna enter 400. Mm, 2 to 3 is 300, 3 to 4 is 400, and this one is 750. And from that, we want to bring back the carriage at the original position. And in here you can see, as we have defined our displacement or the position parameters, it's calculating the displacement, and it's calculating the velocity profiles, and it's showing the acceleration. So with this information, actually you could help to smooth out these accelerations, because you don't want too many jerks. You don't want to have quick speed up and quick stop. That can sometimes, most of the time, it's not good for your machinery. I'm gonna click OK. So the segments have been defined. I'm gonna click OK on the motor, and I'm gonna drag this key, because we need to solve the motion for 6 seconds. So I'm simply gonna calculate the motion. Okay, so the solution is done. So right away, as you notice, my carriage is hitting the this pulley. So one thing I could change is the parameter. Just move the make the changes to this rail, or I could reposition my hole so that there's no interference or there's no hitting. So this is where one of the powerful feature in SolidWorks that can help you to design better. So I'm simply gonna play this one. So as you can see, it's moving fast and then it's going. So this is basically your lab 3A and 3B exercise. Please save your file, and for the submissions you will submit all these files, and there are other things that will be specified on the canvas. Please make sure that your files are submitted properly. So based on this lab exercise, we are giving you an opportunity to earn extra 2% marks, which is associated with the bonus lab. And you can use this, you will use this linear slide, and you will create a 2-axis frame if you want to earn that bonus mark. Well, thank you very much for watching this video.